morning. Welcome to the New Hampshire Energy Geek. In previous videos, we've talked about air sealing, the windbreaker portion of the combo which we need to keep a house warm. The sweater portion is insulation, and insulation resists conductive heat loss. The amount of resistance is described as the R value. So the higher the R value, the more insulating power that you'll get out of the insulation. There are other properties, though, of insulation that we should look at. One of them is how they function if they get wet. And insulation needs to be able to dry out when it gets wet, because often it does, even with the best of intents of how we build things. Also, the manufacture of insulation creates greenhouse gases, and some insulations create more greenhouse gases than others, and this is measured in what's called the GWF, or the global warming factor. So we try to use insulations with the least amount of GWF possible. There's many forms of insulation. And actually, once when I was a baby energy auditor, I opened up a wall and found newspaper from the early 1800s as an insulator. We're going to discuss here the types of insulation with buildings, both in new construction and in retrofits. For the last 40 years, fiberglass has been the most common form of insulation in buildings. Fiberglass has a couple of issues, however, which no longer make it the go-to insulation. First of all, even when it's installed well, fiberglass is not an air barrier. You need a separate air barrier. Secondly, it's rarely installed well. If cracks are left between the fiberglass and any of the surfaces, air can move through and heat is lost that way. If fiberglass is compressed because you put wires or pipes through it and they push it back, it's leaving airspace and it's not going to effectively insulate. Fiberglass has a high global warming factor. There are a lot of climate change gases emitted in the process of making fiberglass. Sometimes fiberglass is used to deaden sound between walls, for example, in a bathroom. Sometimes fiberglass is used to save money in conjunction with spray foam insulation, which we'll talk about in a minute.
This is fiberglass insulation. These are batts. Fiberglass is traditionally the insulation that's been used in house insulation for many years. It does not air seal well, does not work well when it gets wet, but it's great for interior sound deadening. If you want to sound deaden between a couple of rooms, this is great stuff to put in there. Not so good to put in your exterior walls.
The next form of insulation I'd like to talk about is cellulose. Cellulose is ground up newsprint treated with borax to make it fire retardant. They used to put cellulose in walls and found it would shrink and there'd be cavities of air at the top of the cellulose. What they've taken to doing in the last 10, 20 years is putting cellulose into walls under pressure. This is called dense pack cellulose, and this can be done both in new construction and in retrofits.
Well, right now we're just loose filling, backfilling all the bays with insulation. Just because the cavities are so big, they're 12 inches deep, and then we go back with our smaller hose to dense pack each bay after to the density that's needed in each bay, so it doesn't settle, later on down the road and whatnot.
So when you're done, this will be dense packed and no air will get through, and it'll be a very high, 3.5 per inch?
Yeah,
Is it?
then we're doing spray foam in the rim joints.
Uh-huh.
Yeah.
And that's going in the ridge joints up here.
Yep.
Thanks. Cellulose also is used loose in attic floors. Cellulose has an R value of 3.5, and dense packed cellulose under pressure has a R value of 3.7. Another form of insulation, and you'll hear about this in the Zitter-Nadeau house that we are following, is rock wool insulation. Rock wool is better than fiberglass. It's a little better of an air sealant than fiberglass. Made from rock, blast furnace slag, and other raw materials which are melted and spun together into the texture of wool. Rock wool comes in bats, rolls, and loose forms, and it has an R value of around 4 per inch.
Rock wool is a very old insulation. Houses, it's been used in houses since the early part of the 20th century. It's made out of spun rock, so it is non-flammable. Critters don't particularly like it, and it works fairly well as a bat insulation. Very easy to install. Sound deadening, good sound deadening qualities. Rock wool is very good for air sealing also. It's not, any bat insulation has limitations, but this is fairly dense. It comes, these are the bats, you can't see them well. It actually cuts pretty easily. It does break apart, but you can cut it fairly easily with a serrated knife. This is a board that they also make. You can use on the outside of the house. Rock wool, if it gets wet, it will drain because it's made out of rocks. It just doesn't hold water, and the water will drain out of it. So it's a good product for interior or exterior use. So rock wool has been used since the 1920s or 30s anyway, but it has not been used much in the last, say, 50 years of building. We've gone to fiberglass, but the rock wool company has staged a comeback. And this is the comfort board is a new product. It's the first time I've seen it in a store. You can use it on the outside of the house as an insulation and then side over it. You strap it and then you side over it. It's impervious to water, and the moisture can go through it. So it's got a high perm rating.
And it's an R6 for that.
It's an R6 for a 2-inch, 1.5 piece. It's R6. So R4
And
per
48
inch.
square feet is $53 and change.
Yeah, so it's about $1 a square foot.
Interesting. Cool. Moving now to rigid foam insulation. Rigid foam insulation is effective in insulating. It can be cut to be put between studs, but better still, it can be put on a flat surface and used as a thermal break so that it stops. It's on either the inside or the outside of the studs, and it stops the heat from moving from warm to cold through the studs. Without material like this, the studs act as a conductive heat loss, and you're insulating between them. With a break, the studs no longer have that direct path from warm to cold, and you lose a lot less heat. So rigid insulation is a good insulation to use for that purpose. Open cell expanded polystyrene, which is sometimes called EPS, is the same material as coffee cups. It's foam insulation with an R value of 4. It's good in damp and wet places because it's vapor permeable and impervious to water. EPS has the lowest of the global warming factors of the various foam insulations.
We're in the sheet foam department. This is expanded polystyrene. It's unusual. The big box stores seem to sell this expanded polystyrene with aluminum facing, which is a bit weird. You can see in the corner here, it's a coffee cup. It's what coffee cups are made out of, EPS. The nice thing about EPS is that it's usually fairly inexpensive, and it's permeable, so moisture can go through it. The R value is about 4 per inch, and with aluminum foil on it, it will have no permeability. You do not want to use this on the outside of your house, especially 1 inch, because it will be an air barrier and a moisture barrier, and it could cause rot in your studs.
Then you have extruded polystyrene.
The extruded polystyrene has an R value of 5, and it's all branded. So this is Lowe's brand. It's green. It also comes, the same insulation comes in blue. It's called styrofoam. And there's another insulation that comes in pink. But usually you'll see it in one of those 3 colors. It's an R5. It has some permeability characteristics. It also has the highest global warming factor of any of the manufactured foam sheets. So we don't use it anymore because of the high global warming factor. So this insulation here is a different type of foam. It's usually a yellow foam, but it's a polyisocyanurate. It's got an R value of about 6 per inch. It is impermeable to moisture. You can use it in New England, northern New England, in the right climate zone. You need about 2 inches of this material on the exterior to be safe. Less than that, and the wall has to dry to the interior, and it's problematic because moisture could condense in the stud bays.
Are you saying with 2 inches, it never gets down below the dew point?
In the stud bay, yes.
Yeah,
It stays
okay.
above the dew point. Depending on the climate zone. So you could use 2 inches on the outside. You do not want to use less than that. Less than that is dangerous. More than that is fine.
Another type of foam insulation is spray foam insulation. It comes in several types and is used in slightly different ways. Open cell foam comes in a spray foam can in a gun, or the nozzle's like a gun, and it can be used for both new construction and retrofits to seal up small air leaks.
This is a display of spray foams. These are all single part foams, which are good for patching holes. A single part spray foam is moisture permeable, so it will not stop moisture.
And then these 2 sealants here, notice the difference. We've got foam sealant, and then this one specifically says window and door sealant. Why is that, Bob?
The window and door expands very little. So if you're foaming beside a window and you use the expanding foam, it can push the frame of the window into the window, so the window becomes harder to open.
So
that's
you
what
don't
we
want to
use.
use the expanding foam on a window or door.
Right, you want to use the stuff that's made for that use, which is the window and door foam.
Closed cell spray foam is made in 2 separate chemicals that are mixed together at the nozzle as they're sprayed on. This also can be bought in small amounts at your local building supply, or it comes on a truck and they run hoses in with nozzles, and they have a guy dressed up like he's going to the moon in a suit to protect him, and it's sprayed on the walls, it dries, and it is an air sealant and 6.5 R value per inch. So it's, from that perspective, a great insulation. It air seals and it has a very high, relatively speaking, R value.
A two-part spray foam is what the guy in the truck will have. And this is a froth pack. And this box has two containers of foam in it. And one is the iso and one is the poly. And that combines at the nozzle so you can spray a two-part spray foam. If you need a two-part spray foam, you don't need much of it. You can buy one of these froth packs. If you need a lot, it makes more sense to go to somebody that has a truck. Covers 200 square feet at 1 inch thickness.
So that's a 6.5, R6.5 for 200 square feet. Okay.
The downside is there is some outgassing to spray foam. And I once was at a meeting with a deputy EPA regional advisor who was both a chemist and a lawyer, and her comment on spray foam was it's never been life cycle tested and it could be the next lead or asbestos. Not saying it is, but just saying that those are among the concerns. One other concern with spray foam, it's extremely expensive, which is why earlier I mentioned that some people use an inch of it, so they get an R6.5 from the foam, and they get air sealing. This would be on a cavity of a wall, for example, and then they fill up the rest of the cavity with fiberglass insulation, which, if installed correctly, is fairly effective. It's certainly not the same as filling up the bay with foam insulation, but it's an effective insulation. The takeaway is there are many types of insulations appropriate for different situations. So think carefully when you choose. Also, remember that insulation is part of an air and thermal barrier that is going to separate your living space from the outside world. So think carefully about having a complete envelope around your house. Instead of insulation being put up in isolation, make sure that it's part of an overall plan to keep you warm. I hope this has been interesting and helpful. And if I don't see you in the future, I'll see you in the pasture.